All right, thank you, Frank. Ladies and gentlemen, I'm very honored to moderate this first panel. The organizers have asked me to let the science of ROS shine and to introduce an area that probably for, not now, yeah, the first one's black. To introduce an area that probably due to the requirements of brevity, just 3 achievements, was not really covered in the letter. And as you know, ROS was unique in bringing together people from different communities. Who should be free to take it up. He was unique in bringing together people from different communities who shared a common interest. And this is how he founded a number of focused workshops. Some of them continue until today. And the role of this panel is to shed light into the information hiding workshop. And I have the pleasure to introduce John McHugh here, whom I met at my first information hiding workshop, and he was invited by Ross to the very first information hiding workshop in 1996. Then I have to excuse Ahmad Reza Zagdegi, who would also be on this panel, but unfortunately couldn't make it today. He has also contributed to the Festschrift. And then with Diffie, we don't need an introduction. You all know them. I'm very pleased to have you in this session today. All right, so to let the science shine, what is information hiding? So for completeness, maybe Ross has founded not only information hiding, but before that, fast software encryption. Also, that is something of his achievement that's still going on today, but I don't think it's represented in today's Rossfest. Information hiding was the common idea that you want to enforce security properties by making things indistinguishable, but indistinguishable from real. And you can name a number of areas. It could be covert channels in operating systems. It could be digital watermarking at the time where media and piracy came up. And it can be steganography. And of course, indistinguishability is something that cryptographers understand very well. They have essentially all the security definitions around indistinguishability. But the important difference is when cryptographers mean the indistinguishability, they mean indistinguishable between 2 things that are artificial. So the random numbers and the pseudo-random numbers, both artificial, both defined. Whereas when you talk about information hiding, you want to make something artificial, an encoded message, indistinguishable from the real, some cover object that is transmitted on the channel. So let me maybe introduce the system of steganography because it's easiest to explain. Steganography is arguably older than cryptography. And when you encrypt a message and somebody inspects the message on the channel, then they will see that something encrypted has been communicated. So you hide the content of the communication, but not the very existence of a secret message. And steganography exactly has this objective. It tries to hide the existence, the very existence of the secret communication. So you'll exchange an object, for example, a picture, a digitized, a video, an audio file, and it looks inconspicuous, but the recipient, with the knowledge of the correct key, is able to extract the message again. So, and in order to get the message into this cover objects, that's what we call steganographic embedding. Okay, after having introduced you a little bit to the idea of information hiding, my plan is to tell you some things that Ross envisioned when he invited and wrote his contribution to the first information hiding workshop. So what I did is I reread this paper and took some excerpts and interpret and will show to you today how these have led to streams of literatures and achievements that some of you may be unaware of. In the Festschrift, you see 5 of these lines that essentially spin out of his original paper. I will only talk about 2 here. And then I close a little bit with the impact. All right, so now you know how steganography works. And now everybody more or less can come up with an idea of how to embed a single bit into an object, let's say a digital image. But when you want to embed more, then the question is, how do you do this in a way that it's undetectably, statistically undetectable? And if you look at typical cover media, then you discover that they are heterogeneous. So for example, images have edges, where it's harder to predict the value of the next pixel compared to flat areas where it's perhaps easier to predict. And you should probably hide in the areas where it's hard to predict, but because there's less discoverable. And we call this content adaptive embedding. And if you go back to content adaptive embedding, you will find this in Ross's original paper. Let's see if the slides work. I think I've taken the quotes. Is the presentation up? If not, you have the Festschrift in your hand, so we can read it. So yeah, I mean, Ross's papers are so impactful because I think he had this unique way of writing things up. Yeah? So we should really appreciate the words, and I want to read it out here. So of course, not every pixel may be suitable for embedding ciphertext changes to pixels in large fields of monochrome covers, so that, where is it? No. Is it there? Yeah, maybe take this one first. Yeah.
I'm an anti-Windows person, I don't know.
We already see it, yes. So no, good. Let's move here. So this is the paper, 10 pages paper, Stretching the Limits of Steganography. Is Fabien here? I think with him, he then made it into a journal version later that is now, I think, Ross's third most cited paper. And so this is a quote from this very paper. Of course, not every pixel may be suitable for encoding ciphertext. Changes to pixels in large fields of monochrome color or that lie on sharply defined boundaries may be visible. So some systems have an algorithm that determines whether a candidate pixel can be used by the steganographer and so on. So that's the idea of content adaptive embedding. We could probably all have come up with this idea. Still, Ross was the first to put it into this, this framework, and then from there on, it is used all over its steganographic systems. But I was only talking about content adaptive steganography in order to point you to his, in my opinion, even more important achievement, and that is the selection channel. Yeah? So now the problem is you embed this message into the stego object, and the recipient who shares the secret key, but of course does not have access to the original cover object, does not know where the embedding changes have been made. Yeah? So the sender can choose the safest pixels to embed, but the recipient does not know. And what Ross proposed here is the notion of a so-called selection channel. We will use our key stream generator to select not one pixel, but a set of them, and embed the ciphertext bit as their parity. This way, the information can be hidden by changing whichever of the pixels can be changed least obtrusively. Yeah, so this gives the sender an information advantage that they could use in order to hide less detectably. And this is where all the research on covering codes in steganography started. Yeah? The selection channel, you can think of as a very simple version of a block covering code. And then there were notes by Ron Crandall, Jessica Friedrich's students who developed this idea further into very powerful coding, coding theory for embedding steganographic messages. This is the de facto standard right now and can be traced back to the selection channel. For those who are a little bit familiar with coding, I'll give you a gist of what it means. The problem with this selection channel is that you can choose the sets large or small. If you make them too large, then your capacity goes down. If you make them too small, then you may even have a single set in an image where even the least obtrusive choice is a bad choice because you get detected. So what you probably want is you want to merge all these sets together, let them overlap, and then essentially you write it as an equation system that you can solve, and then you're in the realm of coding. All right, there's two more important contributions. You can read about this in the Festschrift. Let me go to the last one, and the last one is on epistemic bounds, because I think it has also value for the future. So Ross very quickly identified what is specific to steganography, that it is about a competition of models modeling the real. Because if you want to be indistinguishable from the real, you have to have a good model of the real. So he writes, the attacker's performance of job depends on his having a model of the source, so meaning reality. And the danger of Alice and Bob, these are the communicating parties, is that his model might be better than theirs. And this again brings us back to this artificial versus real. And I think it's important for the future. It's also one of the last couple of conversations I had with Ross. Because with the boundary of what is artificial and what is real is changing, and we get less and less able to distinguish artificial from real, some fundamental insights from steganography or steganographic security, meaning steganalysis, may become very strong relevance in the future. And yeah, with this, I want to leave you and read the remaining contributions of Ross in the area of information hiding. The information hiding workshop is still going on until today. I think the next edition will be in San Jose this June, and there's an active community. The information hiding workshop was also the workshop that where the original workshop PET spun out. That is now the PET Symposium. So many people are familiar with that symposium, and you can trace the origins back to this 1996 workshop that Ross organized here in Cambridge. And when I want to talk about impact, then what comes to mind is that, of course, he was interested in the science and the engineering, but steganography had a purpose. Yeah? Steganography was used as an argument against regulating encryption in the first crypto wars. Yeah? How can you regulate something that you cannot see? And many of the technologies that are discussed at the information hiding workshop have social implications. Yeah? Whether it's watermarking or whether it's steganography or steganographic protocols for censorship evasion. And I think that ties everything nicely together, that Ross did excellent engineering for the purpose of serving society, of doing something that has real impact. So with this, thank you for the attention for this start of the panel. And I want to hand over to the second panelist, John McHugh, who has many more memories and anecdotes about these first editions of the information workshop. John, I'm very happy that you're here. You just click here, then you get your image.
Okay. I apparently inadvertently wrote the paper that started the information hiding workshop. In 1992, I was working with a group at TRW under a DARPA contract to build a multi-level secure windowing system. And we chose to try to do a version of X Windows that would handle information at different levels. We got a prototype working fairly well on Sun 3 hardware, if you can remember that far back. And I think the best that could be said is that the performance was sluggish but usable. Now, of course, the hardware has taken care of that kind of a problem. But one of the people who was working on the project, Jeremy Epstein, who went on to become a program manager at National Science Foundation and a number of other things, thought TRW should turn this into a product. Never mind that that part of TRW was not a product company, but he got a little bit of money to take the prototype on a roadshow and show it to other defense contractors who were building multi-level secure systems. And he came back saying, they really like it, but it needs an image downgrader. And I said, you mean they want to look at something on the screen and say, oh, there's nothing classified here, press the downgrade button and it goes to the low side. And he said, yes, that's exactly what they want. And I said, they are out of their expletive minds. I had done a little bit of work in text downgrading, which is bad enough. And so I was at University of North Carolina at the time, which had a good graphics group. And I took the problem and mentioned it to one of my colleagues, who threw it out in a graphics research group that met every week. One of the students in that group, Charles Kurak, had been a systems engineer and analyst in the Navy before he went back to graduate school. And so he was somewhat familiar with the domain of the problem. It took him less than a day to gin up an example using graphics libraries that were readily available. He showed me the results of that. And I said, Charlie, this is great. You need to write this up paper and submit it to one of the conferences. And he said, I'm studying for qualifying exams. I don't have time to write a paper right now. So I wrote the paper. I put his name as the first author because he had done the real work on it. and we sent it to the Applied Security Applications Conference, ACSAC, where it appeared in 1992. In the spring of '93, I believe it was, I was at the Oakland Security Conference, and Ross came up to me, and I knew who he was, but I didn't know him at all at that time. And he asked me about a conjecture which is buried deep in the paper, so deep I have trouble finding it sometimes myself, that the information carrying capacity of an image is in some way related to the size of the file that you get when you compress it with the best loss-free compressibility, and the size you get when you compress it with a lossy compression that subjectively gives you back an image that is indistinguishable from the original using the display that is involved in the system. And Ross asked me if I had a proof for that. And I said, that's way above my pay grade in information theory. We talked a little bit more and went away. And about 2 years later, we met again at a conference, and he says, you know that conjecture? He says, one of my students proved it, and you're right. Now, if anybody here knows who did that, tell me. Because I've never been able to find out who did that. But about a year after that, he had the first information hiding workshop, invited me to come. At that time, I was sort of in a position where I didn't have any funding, but I got a trip to Seoul and persuaded the people in Seoul to provide business class airfare from Portland to Seoul. Realized that for a couple of $100, I could convert that into a round the world business class trip. And so I arrived in time to go to the second and third days of the first information hiding workshop in Cambridge. And that workshop built a community. All of his workshops have built communities. And I think the community building is at least as important as the content of the workshops. I was the general chair of, I believe it was the fourth information hiding workshop, which was held in Pittsburgh when I was at Carnegie Mellon. Of the people who presented papers at that workshop, Ahmed should have been here today. Toby Sharp did a practical information hiding system to allow a colleague, friend of his, to communicate securely from a repressive country. And he wrote that paper. He was an applications programmer of some sort in Durham, I think, England, at that time. A year or so later, he wrote and asked me for a recommendation, and he joined the Microsoft Security Lab in Cambridge. He's now a senior researcher at Google in visualization and things of that nature. Ahmed is on the University of Darmstadt faculty. The paper was perhaps most notable for the conference was most notable for a paper that did not appear because the Digital Millennium Copyright Act was invoked against it, and everybody involved was being sued. Carnegie Mellon said that it would defend me. The Naval Research Lab would not defend Ira Moskowitz, who was the program chair, and he basically withdrew from all public-facing activities in computer security, which was a big loss. But the workshop goes on. The other workshops were similar. Their communities started and continue to this day. And I think it's that building of communities, which is as much a contribution as any of the technical work that has been presented at those workshops. I think the audience here is an indication of this, the size and strength of those communities. So, thank you.
Is this my phone? Yes. I couldn't tell whether green meant it was working, you know,
Just
kind of thinking in secure phone terms and so forth. Red would seem to me was working, it was transmitting. So I too was at the first information hiding workshop here at the Newton Institute. And I have to admit, it was 29 years ago, which is prime if that helps. And I barely remember anything except a general feeling of enjoyment. But I think that information hiding is, in a certain sense, I've never published any work in it, but it is, in a certain sense, at the heart of what I set out to achieve, which was, technology in support of freedom. And it's either under development or its universal application is being hidden from me. There's nothing else that I've been involved with, been listened to, that had the same degree of, not sure how to feel about that. I mean, I feel very much in covert communication between individuals. Do I believe in covert communication among CEOs who are fixing prices? No, but if you're going to give it to everybody, they're going to get it. Do I believe in watermarking in support of copyright? Not a lot. I'm not a big fan of copyright. But on the other hand, do I believe that authors of a report that are not going to have the authors listed ought to be able to sneak information into what they wrote that will allow somebody to recognize who each of the authors was? Yeah, I like that one. So as I've looked at this over the last several years, what seems to me is we face a large problem of efficiency and a problem that depends on the model of the censor. And if the censor can make up anything it wants to, then you can't get any information through. At least I believe so. If the censor is limited and can only delete things, or can only change things in such a way that the fact that the censor has done it is not going to be clear to anyone other than people with secret information, then you probably can get something through. But I remember saying once something about Tor this must cost a factor of 3, and they said, well, we wish it were only a factor of 3. And there are classic, I don't know if anybody has yet achieved a video conference that has it inside it. An audio conference is undetectable from the video conference. Right? Probably you can certainly get a text exchange that's insignificant from the video conference. In any event, I am very enthusiastic about this field, and it probably of the things I'm enthusiastic about, probably the one to which I've contributed least. So I'm thrilled with the people who have, and I exhort all of you to press on with it. Thank you.